Okay, it says for each ordered pair, determine whether it's a solution to the system of equations. And when they say system of equations, they're referring to these two equations right here. Now, when you graph two lines, they can do one of three things. They can intersect at one point, they can intersect at no points, which means they're parallel, or they can intersect at an infinite number of points, which means it's actually the same line. Now, if you're looking at one intersection point, that will be the only point that both lines have in common. So they're giving us four different ordered pairs. And if an ordered pair is a solution to this system, it'll check in both equations. So I'm going to start with this ordered pair right here, the 3, 17. And I've already written down the two equations. I'm going to stick the 17 where the y coordinate is. And then I'm going to stick the 3 where the x coordinate is. And I now need to check. The left side is a 17. I need to see if the right side works out to be 17 also. According to order of operations, you would multiply before you subtract. So 7 times 3 is 21. And 21 minus 4 is 17. So I get 17 equals 17. Now, it checks in that equation, but that doesn't automatically mean it's a solution. I have to go over to the other equation and check it over there too. So I take out the x and I take out the y in this equation and plug them in. The x coordinate was 3 and the y was 17. So now I'm going to take, let's see, negative 14 times 3. It's a negative times a positive, so it's a negative, and that would be 42. And then 2 times 17 is 34. And then negative 42 plus positive 34, yep, that's negative 8, which equals the negative 8 right here. So it checks in that one as well. It has to check in both in order for it to be a solution. So I will be saying yes on that one. And then basically you do the exact same thing for all the rest of them. So hang on. Alright, so this time I'm going to do the negative 1, negative 11. So I'm going to stick the y coordinate is negative 11 and the x coordinate is negative 1. So 7 times negative 1 is negative 7, and negative 7 minus 4 is negative 11, which matches the negative 11 over here. It checks in the first one. You must make sure it checks in the second one also. So over here, x is negative 1, y is negative 11. Let's see, negative 14 times negative 1 is positive 14. 2 times negative 11 is a negative 22. And 14 minus 22 would be a negative 8, which matches the negative 8 over here. It has to check in both, so that one's a solution. Okay, this must be the same line. Yeah, okay. Both of these lines are the same, so it's a line on top of a line, but that doesn't necessarily mean that all these are going to work. Next I'll do the negative 2, negative 2, 5. All right, I erased all that. So 5 goes here, and negative 2 goes there. 7 times negative 2 is negative 14. Negative 14 minus 4 is a negative 18. Okay. 5 does not equal negative 18. You do not have to bother checking in the other equation because it has to check in both. If it doesn't check in one of them, it is not going to be a solution. So that one's a no. And then the last one is the 0, 4. Okay. I'm going to do this one in a purpley color. Y is 4 and x is 0. 7 times 0 is 0, and 0 minus 4 is a minus 4. 4 does not equal negative 4, so this one's also a no. So just keep in mind, it has to check in both in order for it to be a solution. Okay? All right, and that's all there is to that.